Jai Hind everyone. I am Dr. Sneha Mishra, Assistant Professor, Department of Computer Science and Engineering, AKTU Ghaziabad. So today I'll be delivering the lecture on Introduction to Compiler Design. In the previous lecture we have discussed about the language processor. We have discussed about the compiler, interpreter, preprocessor, then linker and loader. So now we'll be coming to the basics of compiler design. So what is let me first introduce what is compiler, although we have studied in the previous lecture also, but still let's replicate it. So the compiler is a translator that accepts the expanded or modified source program as the input from preprocessor and converts it into the assembly language program. Basically, if we say that compiler is just converting the source program to the machine readable program, right? So the compiler is translating the program which can be accepted by the assembly language program, right? So if any error is present there, they are displayed along with the appropriate error message and with the line number, so that the user can correct them. So the process of converting from high level language to target language is called the compilation, right? So we are converting high level language to the target language. So this is the work of the compiler. So the entire compilation process is mapped into two parts. The entire compilation process is mapped into two parts: analysis part and synthesis part. There are two parts, analysis part and the synthesis part. So if we discuss about that, what is the analysis part and what is the synthesis part, let us come to this part. So the analysis phase, in the analysis phase, it acts as the front end of the compiler and performs the various activities. What are those various activities? We will discuss one by one. So the analysis phase, first of all, you have to remember is it is a front end of the compiler, right? And similarly to the synthesis part, we say that it is a back end of the compiler. So what are the activities being performed by the analysis phase? Let's discuss those. So it accepts the source program and breaks it into two pieces, imposes a grammatical structure on them. So what does it do? It does in analysis phase, it accepts the source program and then it breaks it into the pieces and imposes a grammatical structure on them. The second activity which is performed is, it then uses the above structure which is generated here in the grammatical structure. Whatever the structure is generated, that generated structure is it uses to create an intermediate representation of the source program. So the grammatical structure which has been developed in the first step, it creates the intermediate representation of the source program of that grammatical structure. So this is the part of the analysis phase. Then it also displays the appropriate error message, right? So in synthesis phase, in analysis phase, it displays the appropriate error message. Error message is popped up whenever there is any syntax error or there is any semantic error, whatever type of error it is encountered during the process of compilation. So that type of error message is being showed or represented in this. So this helps the programmer to correct the program, right? So this step is very useful for the users whosoever are writing the program. If the error is being displayed as per the line number, then it becomes easier for the user to correct that error. Then what is the next activity? It also gathers the information about the source program, whatever is the information about the source program, and then it stores the variables and data in the data structure called symbol table. Along with the type of the data, line number, etc. So in symbol table, it stores all the information about the source program, right? So symbol table is basically the data structure, and in that particular data structure, all the information regarding the source program is being stored. So the symbol table thus obtained along with the intermediate representation of the source program is sent to the synthesis part. So up till now, whatever is being stored in the symbol table obtained along with the intermediate representation which was done here of the source program is sent to the synthesis part. So in analysis part, what are the activities? In analysis part, the first of all, the structure is being checked whether it is syntactically correct or semantically correct. Error message has been generated, and the intermediate code representation is done. So this is the part of the analysis phase. After the analysis phase, whatever we have received till here, this representation is sent to the synthesis part. And in synthesis part, sorry, I have written here phase, but it should be part, right? So in synthesis part, as I told you that analysis part is the front end of the compiler, but synthesis part is the back end of the compiler. So the back end of the compiler process is called as synthesis part, and what is performed by this, it accepts the intermediate representation which was generated in the analysis phase, analysis part of the source program along with the symbol table. Both these things were being developed in the analysis part. Alright, so what it accepts the intermediate representation along with the symbol table from the analysis part, and then it generates the target program or object program as the output. So it generates the target program or the object program as the output. So it receives the analysis, receives these things from the analysis part, and then it converts, it generates the target program as an output. So this is the synthesis part. So covering this, we have these are the phases of compiler. Since we are studying about compiler design, so these are the 6 phases of compiler design. So in these 6 phases, there are lexical, and one by one we will discuss all these phases. So lexical analysis, syntax analysis, semantic analysis, then intermediate code generation, then code optimization and code generation, right? So now, and also you may understand that these all are the analysis part. And these are the synthesis part. Right, because these errors are being checked on and intermediate code is being generated in the analysis phase. When this particular thing is being generated, it is given to the synthesis part, and after synthesis part, our program is being compiled and we receive the target input. So if we see that how the compilation process is done, let's take the diagram clearly. See, at every stage, it is connected with the symbol table. What does that symbol table do? It is actually a data structure. This symbol table is actually a data structure, and the data structure in which all the information about our source program is being covered is this. This is stored in the data structure which is called as symbol table. So what happens is this phase, all these phases are connected with the symbol table. That is why only now we can get the line number of the error message. How will the error message be generated if all these phases are not connected? Suppose if the error is at this stage, so the symbol table will tell that line 4 this is missing, right? Braces is missing. So line 6, right? If this particular message is being generated, how it is generated? Because it is gathering the data of every line, information of every line. So this symbol table is the data structure which is storing all the, and this error handler, what it is doing? It is also connected with every stage. Why it is connected with every stage? Because we have to receive the errors also, and how these errors are being how these errors are being handled. This also is uh, this error handler's job. So see, you can see we have these 3 synthesis part and these 3 as analysis part, right? So you receive a source program, and in this source program, what is the next step? You do the lexical analysis. I'll tell you what is the lexical analysis. Then you are doing the syntax analysis. After syntax analysis, you are doing the semantic analysis. After semantic analysis, you are doing the intermediate code generation. After intermediate code generation, you are doing code optimization, and after code optimization, you are doing code generation. And what in return, you are receiving the target program, which may be your assembly language, right? Or you can also say it as machine level language, right? So these things can be done in this. So if I talk about these phases separately, so all these phases do have certain jobs. This will be discussed further, that what every phase is doing. But before that, it is very much required to understand how the compilation is working. The compilation is about, and how these analysis phase and error and the synthesis part is being covered. So analysis part and the synthesis part both are the part of your back end and front end of the compiler. So analysis works, in the previous slide I have mentioned that the analysis is the front end of the compiler, and it performs the first of all it breaks the program into the pieces of grammatical structure. Then these grammatical structures are represented as intermediate representations. Then error messages, if there are any, are encountered and been generated. And after that, the whole information about that structural program or the source program, including variables, data, data type, everything is being given in the symbol table line wise, right? So what type of data we are using, what are the variable, what is the data type of that, everything is being stored in the आपका symbol table. And then this symbol table is, and also the intermediate representation is given to the synthesis part. So both synthesis part and the analysis part both play a very vital role in the phases of compiler. So then this, yeah, this is not in the analysis part. These 3 phases are in the analysis part, and these last 3 phases are in the synthesis part. So this is the front end and this is the back end of the compiler. So these are the all the phases of the compiler. One by one we'll be discussing these phases of compiler in the next lecture. And I think we'll continue in the next lecture about all these phases, what lexical analysis, what syntax analysis, what semantic analysis, and intermediate code generation, code optimization, code generation. So in lexical analysis, we do tokenization, right? Suppose if we have written A is equals to B plus C. So each and every variable, each and every symbol, operator, it is a token. So I'll say this A as token 1, this equals to as token 2, this B as token 3, this plus as token 4, this C as token 5. So this tokenization of the whole program is being done in the lexical analysis phase. Then in syntax analysis, what we do? In syntax analysis, we have generated the tokens, right? So in syntax analysis, what we do? We continue with this this particular program. We generate the parse tree. We generate the parse tree, and we check whether the program is logically correct or not. This is being done in syntax analysis, and we also check the ambiguity, right? So this all is being checked in the semantic analysis, in syntax analysis. And in your semantic analysis also, the parse tree is generated by removing all these ambiguity and checking whether the program is logically correct or not. This parse tree is generated. In intermediate code generation, what we do is, we develop the intermediate code like in the form of registers and all. So this is done in intermediate code generation. What do we do in code optimization? We reduce the number of lines of the codes, whether suppose we have written this A plus A plus A, right, plus A many a times. So how can we optimize this line of code? This all is being done. There are some replications, or we can use some loop and all. So the code is being optimized. Whatever code it is being generated by the intermediate code generation, that is being optimized by the step that is code optimization. Then code generation. What does the code generation do? Code generation is about whatever we have received from here, we do the we represent it as in the assembly language. So that is the code generation. And as soon as we generate the code, we receive the target program. So these are the steps, these are the little basic details about the steps. What are these lexical analysis, what are these syntax analysis, semantic analysis, intermediate code generation, and code optimization and code generation is doing. So these are the small explanation about these steps. Next we will be covering in the detail about these each and every phase we will be covering in next lecture. That will be the detailed lecture of the phases of compiler. All the phases with examples will be covered in that lecture. So thank you.